Okay, pre-calculus, Monday, March 16th, online learning day number 1. Here we go. So Friday we talked about using SOHCAHTOA on right triangles. So what happens when we can't use SOHCAHTOA because we're not using right triangles? So at that point we're going to use something called law of sines or law of cosines. So that those equations, formulas will help us use or help us solve for non-right triangles. So without further ado, let's get into it. Those of you that were here Friday, we talked about making sure our calculator was set in degree mode. If you're not in degree mode, you will not be getting the same values that I will be showing you. So please make sure you're in degree mode. This is what you guys are going to want to copy down in your notebook. So this whole law of sines with a new table of contents and a page number. And so this is probably a good point to pause the video and make sure that you guys have this copied down. I'm going to go ahead and continue. So you may decide to keep going or stop it and copy it down. So law of sines works for 3 different types of triangles. Angle-angle side triangles, angle-side-angle triangles, and what I commonly refer to as a donkey triangle. Because for obvious reasons, if your mom's watching this video, I don't want her to think too badly of me. So that's a triangle that didn't really exist in geometry, but these two did. And here are pictures of what each one of them would look like marked up. So you can remember back to what you did back in geometry. The little boxed off area here is the actual law of sines. This is the formula that we will use to solve non-right triangles. Again, if you were not here on Friday, we talked about how big A is opposite of the side little a, and vice versa for all of the angles and sides. And this is going to be important as you're setting up your triangles to know what side goes where. As you start to look at the actual formula, the sides are what is written on top of each fraction. The small letters refer to the side lengths, and the angles will be on the bottom. And please note also that corresponding letters are on top of each other. So little a is on top of big A, little b is on top of big B, and little c is on top of big C. All right, let's get into a problem. So this first problem that we are going to look at, it asks us to find all 3 sides and angles except for the fact that they gave us 3 of them. So we really don't need to find 6 pieces of information. We only have to find 3 pieces of information. And this is also an angle-angle side triangle. So as I referred to it earlier, this is an angle-angle side. So law of sines only works for these 3 types of triangles. And today we're only going to be doing the top 2. Tomorrow we're going to work on what's called the ambiguous case, the one that doesn't really exist. So let's look at how this works. So what we're dealing with is one big proportion. And proportions are solved using cross multiplication. So you're going to take a look at your 3 fractions and find out which 2 of the 3 you can use. For instance, if we tried to cross multiply using the first and the second fraction, there's not enough information. You'd have too many variables. So you got a little a and a big A that you're trying to find, and you just can't do that. It's too many variables. So what we'll do is we'll take a look at the second and the third triangle, and we'll try to cross multiply those. And we notice that we can actually do that because there's only one variable. You're finding little c. So as we use cross multiplication, I'm going to type this out just because it's cleaner. This is going to be 27.4 sine of 102 28.3, which is going to equal little c sine, well, I'm going to use a big S there, sine 28.7. Now, since we just did cross multiplication, remember, we cross multiplied, there's a multiplication symbol right there. And so we will use division to get rid of that sine of 28.7. So we will go and divide by 28.7 on both sides. And we will find little c, which I have on the next screen using the calculator. So I'll show you now what it's going to look like when you type in your calculator. So sine 27.4 sine of 102.3. Now, as you're typing this in your calculator, you have to type this parentheses in. Otherwise, everything will mess up. And then you can divide it by sine 28.7. That answer for little c is 55.7. So we have our first answer of the 3 that we're looking for. So little c was 55.7. We can put that over here. Oops. Right there. And we can get rid of the little c up top. And we can put it up here too, because every now and then you do have to reuse these fractions. All right. So that's not the first calculation I had to have made. Hopefully you remember back from geometry that the triangles, all triangles sum to be 180 degrees. So it is possible that I could have used that triangle sum along with the 2 angle measures that were given to us, 28.7 and 102.3, and subtract them from 180 degrees, which is going to give us angle A, which is 49 degrees. And once again, I have that calculation for you right there at exactly 49 degrees. So we now have 2 of the 3 pieces of information we were looking for. We just figured out that A was 49 degrees. And so we can get rid of here, we can get rid of the big A, and we can put our 49 in there. And the reason we want to put this back into our formula, back into the law of sines, is because in order for us to find little a, we now have to, sorry, let me go back to the pen. We now have to cross multiply the first and the second equations to get the final answer. So let me screenshot this so we don't have to keep scrolling back and forth. Yes, you did work. It's right here. So we'll move this down to the bottom so we can have some room to work. Make it just a little bit smaller, and we'll start our cross multiplication. So once again, we'll cross multiply A times sine 28.7. So let's go with red. A sine 28.7. That's going to equal the 27.4 times sine 49, 27.4 sine 49. Our variable is A, so we will divide by all of sine 28.7. Let's see if I can copy that. Good enough. These right here will cancel, leaving us with little a is going to equal our calculation of 43.1, which finishes off that problem for us. So we got little a at 43.1 degrees. We'll scoot up here, put it in our answers, 43.1. And so that finishes off this problem. Yes, it's a big problem. When you get to your Delta Math homework, you'll only have to find one solution. Okay, so let me show you one more example. This time it's a side angle side. I'll try to rush through this. Remember, you can always stop, replay, rewind. So I'm going to get through this semi-quickly. I'm going to go ahead and put my fraction, my proportion together. So the only angle measure I have is 32 degrees. So that's going to be sine 32 on this bottom fraction. I have a side length of 3.4. 3.4. I've got another side length up here, 6.2. I do not know angle B. I do not know little c. And I do not know big C. So when you look at the three angles, the difference between the previous problem and this one is I only have one angle measure. So I can't subtract from 180 right here. I've got to go through the law of sines in order to find my first calculation. So we will use this first fraction and second fraction right here. We'll go through the cross multiplication, which is 3.4 sine of d equals 6.2 sine of 32, which of course for the new problem we get new challenges. This time we're multiplying 3.4, so we're only going to divide by 3.4. Which, so when we're done with this, we're going to have sine of b. Whoops, where'd b go? B. We're not done yet. We only have sine of b. So we're going to have to finish that calculation after we do the division. So here's the division. Sorry. Here's the division. 6.2 sine 32 divided by 3.4, which gives us 0.966. Now, hopefully you're saying, well, that can't be the answer. And you're right, because that's only sine. So we're sitting here at sine of b equals 0.966 and some other stuff behind it. So remember, in order to get rid of sine, you have to use its inverse. So we're going to have to do sine to the -1 power to get rid of that. We have to do its inverse. Can't divide by a sine. You have to use its inverse. Sine is not multiplication. So that calculation gives us b. And so on the next slide, of course, we have the calculation. The inverse sine, you can just type in a and s, which is, it'll be second negative on your calculator, which gives us 75.1 degrees. So we get 75.1, which is our second angle measure that we have, 75.1. Angle B, come on, 75.1. Come on, 0.1. There you go. So 75.1, which now allows us the ability to go and subtract, because now we have two angle measures. All triangles added to be 180 degrees in the angles. So now we can find C by just using subtraction. C is going to equal 180 minus 32 minus 75.1. So big old C. We're not doing this problem down here, guys. So we'll get rid of that. That's just in the way. So C is going to equal 72.9. So we got a 72.9 degrees for angle C, which we do need to put up into our law of sines, because in order to find little c, we have to have its angle measure. So one more quick calculation. We'll finish this at 72.9. We get to move our cross multiplication over to the second and the third fraction. We'll snip this. Almost done, guys. You can replay this all night. Move this down to the bottom so we have room to work. Okay, so we'll cross multiply. Let's go change our color. Make sure we're in blue. All right, so we have 6.2 sine 72.9. That's going to equal sine 75.1. And I probably should have put the little c up front. Okay, I'm hoping you're going to tell me that we now are supposed to divide by sine of 75.1. We'll copy this because it's a lot cleaner. Divide by 75.1. We get cancellation right here, leaving me with little c. So now it's just one more calculation. We got a good division right here, 6.2 sine 72.9 divided by sine 75.1, which I'm sure you know I have. And there it is. It's 6.3, 6.1. So our final calculation for little c, 6.1. And there you have it. This was, if you remember what we talked about on Friday, we talked about how the sides 75.1, 72 are pretty close together. That's why side B and side C are pretty close together. Did I have my calculation right? Did I write the right answer? 6.1, yes. Okay, so that's two different types of law of sine problems. When you get to your Delta Math homework, you have 15 law of sine problems, but the good news is you're only finding one answer per question. The questions that we just did, you had to find 3 different things. So you're only finding one question. You're answering one answer per question. The problems are set up that there's no penalty. You just need to keep working problems till you kind of understand it. Good luck, guys. I look forward to hearing from you. Talk to you soon.